Hey everybody, it's time to go on a journey of mathematical discovery into the Pythagorean theorem part 2. We're going to flip it around and do the converse. Behind me on the board, you can see the notes from this week when we did the Pythagorean theorem. But now let's talk about the converse. So go ahead and title your paper Lesson 2, the converse of the Pythagorean theorem. And I wanted to show you that I abbreviate the word theorem with a T, H, and then an M in the air, and I just underline it. I saw my college professor do that junior year of college, and I thought it was super cool, and I've done it ever since. Here's the date for the weeks in which this video is going to be used for. I didn't have to put math 8. I shouldn't have put that because then I had to squeeze in the textbook pages, 373 to 380. Okay, so but the converse of the Pythagorean theorem, and the first thing we're going to do is the Pythagorean, so sometimes I just abbreviate it, Pythag, in other triangles. This is the spark your learning question. Okay, so our I can statement, which is really just the objective, written as an I can statement, if you ask me. Prove the converse of the Pythagorean theorem and use it to determine if a triangle is a right triangle. I can determine whether three side lengths form a Pythagorean triple. Well, we know about that, right? Pythagorean triple 3, 4, 5, 5, 12, 13. Talked about that last video and last week. All right, so let's investigate our other triangles. Let's draw a triangle that looks like this, and we'll say it's 4, 4, 4. I don't know, 4 feet, 4 miles. It could be 4 something. But anyway, it's 4 units on each side. Is that a right triangle? Is this a right triangle? Well, guess what? We can use the Pythagorean theorem for that reason too, to investigate. So remember, the Pythagorean theorem is a squared plus b squared equals c squared in a right triangle. So it stands to reason that if the triangle is not right, a squared plus b squared would not be equal to c squared in a non-right triangle. Hey, okay. So the important note is that C is the largest value of your value. So in a right triangle, C is across from the right angle. Well, we don't have a right angle here. Maybe it's not drawn to scale, but there's no right angle. So where is C? Well, we're just going to have to pick the largest value. And since they're all the same, it just doesn't really matter where we put A, B, and C. So let's just call that A, B, and C. And is it true? Is 4 squared plus 4 squared equal to 4 squared? Is 4 just like a weird number like that? Well, 4 squared is 16, 4 squared is 16, and 4 squared is 16. 16 plus 16 is 32, not 16, which means that if we want to label this triangle, when you label a triangle, so you label the angles with capital letters. So we can just label this triangle CMI, almost CMIT. Okay, so then we would say triangle CMI is not a right triangle. So it doesn't always work, right? This one's actually called, it is an acute triangle. Okay, and the reason there is, and let's keep going, because a squared, if you notice, a squared plus b squared, not only was it not equal, it was greater than. 32 is greater than 16, right? So when we add those two values together, they were greater than c squared by itself. I think for the purpose of our course, you just need to know it's not equal, but because I'm going here, I want to just show you one more example. Okay, so let's say we had a really long side, maybe 15, and then we had two sides, maybe 10 and 6. Okay, so this triangle is 10, 6, and 15. So 15 has to be the C, right? Because it's the longest side. We can just make our shortest side A and our middle side B. Let's check. Check A squared plus B squared equals C squared. Do you think it does? Do you think it's a right triangle that I just messed up? Let's check it out. So I'm going to do 10, oh no, I'm going to do 6 squared plus 10 squared equals 15 squared. And I guess I should put a question mark because I don't know. That's the whole point right here. 6 squared is 36. 10 squared is 100. 15 squared is 225. Add these together, that's 136. Uh-oh, I don't know if you guys see this, but 136 is not equal to 225. So we can say not a right triangle. Okay. And for the extension, what kind of a triangle is it? Okay. Well, we found out that in this one, when the two sides added and squared were greater than the third side, it was an acute triangle. Raise your hand if you know the third type of a triangle. So we know we have right triangles, acute triangles. What's the third type of angle? The third type of an angle is this one up here. That's called an obtuse angle. Any triangle with an obtuse angle is called an obtuse triangle. And so we're going to say because a squared plus b squared, when we added and squared those two shorter numbers together, even added together, they weren't enough to be c squared, right? 136, much less than 225. 136 is less than 225. So means, and so what do we want to call this triangle? How about DOG? DOG, okay? Having some fun. Triangle DOG is an obtuse triangle. All right, so it's an obtuse triangle. Wow, I did all that from the Spark Your Learning. I wonder what we still have to talk about from the book. I wonder if I talked about anything in the book. I think I did. And look, we can see in the book they have named their triangles just like I did. See, I knew it was going to be a need. All right, so we're going to start out with this word converse. I am going to, I guess I'll write that at the bottom of the page and I'll be right back. Okay, there we go. So a converse is, so the converse of a theorem reverses, goodness, reverse, you know what, that says reverses. Is that any better? The hypothesis and conclusion. Here's an example to illustrate. If triangle ABC is a right triangle, then a squared plus b squared equals c squared. That's the Pythagorean theorem, PT, right? There's a picture. But the Pythagorean theorem converse says if in a triangle a squared plus b squared equals c squared, then it is a right triangle. In the Pythagorean theorem, you have to know it's a right triangle for the equation to be true. The converse is saying that, guess what? If the equation is true, then you know it's a right triangle. It's backwards. And actually, that's the one that we use in real life more than anything else. When a carpenter wants to make sure that, so here's an application. I was talking to my friend one time, and he's a carpenter, or at least he hangs drywall and stuff like that. So this is a wall. Okay, and if you know anything about a wall, it has to be perpendicular to the floor, or your wall is gonna fall. So you need a right angle right there. 1 second. Woo, okay, I am back. So let's finish talking about this application. So if you have a wall and you have the floor and you are a carpenter, you need a right angle right there. So how can you make sure you have a right angle? What you could do is you can measure about 5 inches. You can measure 5 inches, 5 inches up the wall, and you can measure oh no, not 5 inches. You maybe 4 inches and 3 inches, 3 inches, and then that's going to be 4 inches. And then you want to make sure that when you put a stick, the length, straight length from the end of the 3 to the end of the 4, if this is a right angle, then this should be 5, right? We know that 3, 4, 5 is a Pythagorean triple. Do you remember that? Because 3 squared plus 4 squared equals 5 squared. Okay, so now let us go back into the book here, and it's a lot of words, but you're not afraid of that. Okay, side A measures 4 inches, side B measures 6 inches, side C measures 8 inches. And the directions given each set of side lengths determine whether each triangle is a right triangle. So 4, 6, and 8, what do you guys think? And so we're just gonna kind of do that. So try 4, 6, and 8. So the first thing we're gonna do, so I can label sides A, B, and C. And we want C is largest side, if there is a largest side, right? So this is going to be A, B, and C. And so I can sub into the Pythagorean theorem. So then A squared, oh, now I'm just writing it. I'm rushing. Okay, so 16. Now I'm really rushing. End of the day. Okay, so 4 squared plus 6 squared equals 8 squared. Is it true? Let's see. 16 plus 36, is that equal to 64? I sure hope so. But I don't know. Let's check it out. So 36 plus 16, and 6 plus 6 is 2. And we have the 1, so that's 4, that's 5, that's 52. So 4, 6, and 8 is not a right triangle. 52 is not equal to 64. So 4, 6, and 8 are not sides of a right triangle. Wah, wah, wah. What kind of a triangle would they be? Well, if C squared is bigger, just so we all know, it's an acute triangle. Remember that? Wait, is it an acute triangle? No, if c squared is bigger than them put together, it's an obtuse triangle. But all you need to know for now is that they are not a right triangle because a squared plus b squared do not equal c squared. If you got that much, you're good to go. Let's try another one. The second example is 5, 12, and 13. And I think we already know about that one, but we're just going to verify, trust, and verify. So try 5, 12, and 13. What do you guys think? So let's label. Oh, and my third success criteria. So I can label sides A, B, and C. I can sub into the Pythagorean theorem. I can determine if a squared plus b squared is not equal to c squared, right? Is that what we need to do? Or if it is. So, okay, so can we label our sides A, B, and C? A is going to be 5, B is 12, and C is 13. I'm going to write my Pythagorean theorem, which we know by now. And I'm going to substitute in. And I'm going to can I determine if a squared plus b squared equals c squared? Or if it doesn't? Let's see. So 5 squared is 25. 12 squared is 144. 13 squared is 169. Now I'll add these two numbers together over to the side. 4 plus 5 is 9. 4 plus 2 is 6. Look at that. Okay, so that is exciting to me. Okay, so that means 5, 12, and 13 are sides of a right triangle. Boom. Okay, the sides of a right triangle. So that was the big learning for this lesson. Let's just turn the page and make sure we didn't miss anything. 3 says, determine whether each set of measurements is a Pythagorean triple. Remember, a Pythagorean triple is a set of 3 integers that can be the lengths of the sides of a right triangle. I did notice that a lot of people on today's unit test, they didn't know what an integer was. So let's just define the word integer to be positive and negative whole numbers. Okay, so if they tell you to put things between 2 integers, what 2 integers is 7 in between. 7 is in between 6 and 8. Those are integers, or you could even do the negative. Negatives are integers, and positives are integers. Okay, so Pythagorean triples are integers. 5, 16, and 20, that's just another thing. And we better do this one. We better do this one as our final one, because then it gets into practice. So the square root of 3, 4, and 7 is that, what are we actually trying to do? Determine whether each set is a triple. Okay. So let's see. 3, 4, and 7. Last one. Are you ready? Can you do one more? The square root of 3, the square root of 4, and the square root of 7. And we can still do it, okay? A squared plus b squared equals c squared. The square root of 3 squared plus the square root of 4 squared equals the square root of 7 squared. Does it? Well, the square root of 3 squared is 3. The square root of 4 squared is 4. So notice what those square root and the square, they're inverse operations, so they undo each other. And the square root of 7 squared is, do you know it by now? 7. Is 3 plus 4 7? It's about 6, 7. It's 7. It's 7. Okay, so that means that the square root of 3 and the square root of 4 and the square root of 7 form a right triangle, but the square root of 3, the square root of 4, the square root of 7 form a right triangle, but they are irrational numbers, right? These are not in our perfect square list. Not integers. So they do not form a Pythagorean triple. Notice I jump back and forth between writing Pythag theorem and PT. You do the same. All right, just know what it means when you take notes. And the rest we will do in class. I will see you there.